And now solving the same equations, but now in the method of elimination. So now on this one, we have the first equation again in slope-intercept form. We need it in standard form like this one. So therefore, we need to do the inverse of the 6x and take it to the y. So to do that, if we have, I'm going to do it better over here in the corner. So if we have y equals 6x minus 11, we can do the inverse of 6x, which is negative 6x to both sides. And then we will have negative 6x plus y equals negative 11. So now we have it in standard form, and we can use it with this bottom one. So I'm going to erase the top one because we didn't change anything. We just did the inverse operations, which kept the equations equivalent and balanced. So now I'm going to put this equation that was a previous one. We just changed it into standard form. So now, what does it mean? Elimination. So the whole process and the whole point of elimination is to either eliminate your x's or to eliminate your y terms. So if you notice, the easiest thing is that since down here we already have a negative 3y, we can multiply this top equation by a positive 3, all the terms, and that will convert this into a positive 3y, which would be each other's inverses, each other's opposites, so then they would cancel, and that's canceling means to eliminate them. So we can take that step, or we can choose to multiply this bottom equation by negative 3, because negative 3 times negative 2 will convert this into a positive 6x, and now these will be each other's inverses, and we can go ahead and eliminate the x's. So either way you want to do it is correct. There's no right or wrong. So I think for the easiest sake of not messing with negatives or positives, let's multiply this entire first equation by a positive 3. So when we do that, we need to do distributive property again. So we have to multiply positive 3 times negative 6x, and then positive 3 times y, and then positive 3 times negative 11. So then that new equation will become negative 18x plus 3y equals negative 33. Do not forget to multiply the 3 with the negative 11, because a lot of students usually forget that. That's number one mistake. And now we can look at these equations, and we can go ahead and eliminate our y's because they're opposite. A negative 3y cancels with a positive 3y. And now you owe me 2 x's, you owe me 18 x's, and you owe me 20 x's. And then you have you owe me $7, you owe me $33, and that means you owe me $40. And now we do the inverse operation of multiplication, which is divide both sides by negative 20. And we found the same thing, that x equals, my Lucha Libre man says, a negative divided by a negative is a positive. When you cover them, it shows a positive. Negative 40 divided by negative 20 is a positive 2. So now we're going to do the same thing and plug it in, substitute the x equals 2 into any of the equations. It doesn't matter. They will all equal the same thing. So you could notice that it will equal the same thing. I'm going to use the second equation better. So then that means we have negative 2, and now we're going to substitute into x. We move x, and we plug in the positive 2 that we found for it, minus 3y equals negative 7. So this is going to give me negative 4 minus 3y equals negative 7. We do the inverse of negative 4, which is positive 4. This will cancel. We have negative 3y equals negative, you owe me 7, but you have 4, so you go pay, then you only owe 3. And now we do the inverse of negative 3, which is divide both sides by negative 3. This will cancel, and we have y equals negative 3 divided by negative 3. My Lucha Libre says it's a positive 1. And we found the exact same solutions we found before, because it's the same equations. We're just using different methods to solve. And now we put our order pair, which is our solution. X is 2, y, our solution was 1. So therefore, this is our solution, which is the point of intersection when you graph these lines. They have one point of intersection. That's 2, 1. That's your order pair. And there it is, elimination. La la.